All right, so we're going to take a look at our last chapter, which is chapter 11. We're going to do 11.1 today, and we'll do half of 11.2 tomorrow, and then that'll be it. So we're going to start out by looking at what's called a sequence. So goal in this section is I'm going to be giving you a list of numbers, and we want to be able to predict the next number in the sequence. Okay, so it's a very different kind of math than we've been doing. It's not really solving an equation or graphing. It's more predicting a number.
Can I ask my genie friend for help?
Not during the test.
Oh.
Okay. When we're predicting, if you're just trying to predict like the next number, that's not usually too bad. When you're trying to predict, let's say at a term, you knew the first 4 or 5 numbers.
Oh, is this like the nth term?
Yeah, and I said to you to predict like the 70th term, the nth term. We need a formula that's going to give us a way to do it quickly. We don't want to have to try to figure out 70 terms by hand. So let's look at that sequence. First, when you name a sequence, generally it's a lowercase letter. Okay, this particular sequence I called B, okay, sequence B. The number that's small and a little bit lower, the subscript, that is the position. So B1 means in sequence B, what's the first number? B2 means what's the second number? B3 would be the third number. Okay, so that number tells you the position. And then usually the last term is just called the nth term. We don't know where this particular sequence ends. It ends somewhere, but it could end at the 100th term, 200th term. The point is it ends somewhere. Okay, there's 2 types of sequences. There's ones that end. Those are called finite because they stop. And then there's ones that are infinite. That means they go on forever. The way you would know something goes on forever, you would see that. Okay, if you see a ... on the end, that means it keeps going. No ... it means it has a stopping point somewhere, okay? Even if you don't know where. So the goal is going to be to figure out a formula to calculate any term that you want to know in the sequence. So like if I said, what's the 15th term in that sequence, hopefully you can see the pattern. It would be 1 over 15. And the way I did that is I looked at the pattern, figured out the formula in my head. If I wanted the 20th term, it would be 1 over 20. In this particular sequence, it's just 1 divided by the bottom number is the position. Right, so that's the key. We've got to be able to find a rule or some kind of formula for finding the nth term. All right, so we're going to look at an example sequence now and just see if you guys can figure out what the pattern is. When you have a pattern of numbers, there's 2 ways you can figure out the pattern. One way is if I said to you to find the 50th term, you have to find every single term up to 50. Not the best way. Or you can just find the 50th term directly. Okay, that's the better way. All right, so let's look at this one.
Plus 3.
So the pattern each time is plus 3. What are you plussing 3 to?
The previous number?
The previous number. So if I wanted that term, what's the term before it in general?
A2.
It would be A2, and you would add 3. That's basically what was just said to me. To find a specific term, take the one that comes before it and add 3 to it. All right. So now let's write that. Let's try it for like this one. How would you find the 10th term?
A9 plus 3.
Right. You take the 9th term and you'd add 3. Now, in this one, do you know the 9th term? No, so you'd have to find that one first. How would you find the 9th term? You'd have to take the 8th term and add 3. Now, do we know the 8th term? No. So doing it that way is okay, but you have to find every single term up to the one you're looking for. So like if I said to find the 10th term, you'd have to find the 9th one and then add 3 to it, but you don't know the 9th one. So then you'd have to find the 8th one and then add 3 to it, but you don't know the 8th one. So you got to work your way all the way back till you find one that you know. Right? And again, it's an okay way to do it, but it takes a long time. So let's say we wanted to find this term. What's the one before a sub n?
We don't know.
A sub n minus 1.
A sub n minus 1. So that is one way to do this in general. To find a term, take the one before it and add 3. And that's fine. It works, but it's going to take a long time, especially if you want like the 500th term. Okay. Now, there's another way to do it. The other way to do it is to, instead of looking at what you do to the one before it to get that one, look at the position number. Is there something you can do to 3 to make it an 8? Is there something you can do to a 2 to make it a 5? Something you can do to a 4 to make it an 11. It has to be the same thing for all of them. Did anybody see what you can do to that number to turn it into that number?
Add 7.
Because you can't.
No, I know.
It works on that one, but yeah, it doesn't work on that one.
You times it by 3 to subtract 1.
Yes. This plus 3 kind of gives you a hint that it's going to involve timesing by 3.
But
Let's try that and see what happens. Plug in 3. What's 3 times 3?
9,
Minus 1?
8,
8. Let's try plugging in 4. 3 times 4?
12.
12 minus 1?
11.
11. So now, if I wanted to know the 100th term, just plug in the number 100. What's 3 times 100?
300.
Minus 1? So the 100th term is going to be 299. That's a much easier way to find it. Doing it the bottom way, I can find it right away just by plugging in the position I want to know. Doing it the top way, I'd have to find the 99th term and then add 3. But I don't know that, so I need the 98th term, and the 97th, all the way back to the beginning. Okay. So there's a name for each of these, but that one is better. And the downside is that formula is usually a little harder to come up with. Okay? How do you figure out that you triple it in minus 1? Well, there's a trick for this kind of pattern I'll show you later on. So any questions on how both of those will give you the correct result? It's just the bottom one is a lot better. Okay? A little harder to come up with, but it's a lot better. I already kind of said this to you, so an infinite sequence. Let me word it. I'm going to just word that a little differently. So an infinite sequence is a sequence that goes on forever. So an infinite sequence goes on forever, and the way you know that is it would end in a dot, dot, dot. That's an infinite sequence. Opposite of infinite is finite. So a finite sequence is a sequence that stops. Okay, so a finite sequence is a sequence, we'll just say that has an end. What if a sequence had a million numbers in it? Is that infinite or finite?
Finite.
It's still finite. It's huge. It's a lot of terms in it, but it still stops. Okay. So a finite sequence can be huge, really huge, billions of numbers, but it still stops. Okay. Infinite goes on forever. Any question on the difference between an infinite sequence and a finite sequence? All right, so let's practice listing some terms. So I'm giving you a formula. And to find a specific term in the formula, you're going to replace n with whatever term you want to know. So if you want to know the third term, replace n with 3. Fourth term, replace n with 4. So it says find the first 3 and then the 15th term. Okay. So to find the first term, what would I plug in for n?
51.
To find the first term.
1.
1. So let's plug in 1 and do it up. Okay. What's 1 squared?
1.
1 minus 1.
0.
So 0 divided by 1 gives me
0.
0. Yep. So that is the first term in the sequence. 0. Okay. Second term. What are we going to plug in for n now?
2.
2. Let's do part of it out. What's 2 squared?
4.
So 4 minus 1
3.
divided by 2. 4 minus 1 gives me
3.
3 divided by
2.
2. That's the second term in the sequence. And they could ask you to list as many as they want. Okay, we're just going to do the first 3. And because of the kind of formula this is, we can jump right to the 15th. We don't have to find the 4th, the 5th, the 6th, 7th, 8th, 9th, 10th. We don't have to find all the ones in the middle. Because this is the better kind of formula. All right, what are we going to plug in to find the third term? 3. What's 3 squared?
9.
So 9 minus 1 divided by 3. 8/3. And 15th term. What are we going to plug in for n there?
15.
15. What's 15 squared?
225.
225. And when we simplify, what's in the top?
224.
224. If we didn't have that better kind of formula here, we would have had to find the 4th, the 5th, the 6th, 7th, 8th, 9th, 10th, all the way up to the 15th. But we were able to skip it. All right. So any questions on using a formula to list terms in a sequence? That part's pretty straightforward. Let's try same thing on this one. All right. What are we going to plug in for n to find the first term?
1.
Yep, plug in 1. And we're going to multiply. What's negative 1 to the first power?
1.
Negative 1. And what's 2 to the first power?
2.
2? Yes. Yep. And what's negative 1 times 2?
Negative 2.
Negative 2. That's the first term. All right, let's do the second term. All right, so the second term, we're going to fill in
2.
2. So you're going to have negative 1 squared times 2 squared. What's negative 1 squared?
Negative 2. Oh. 1.
1. And 2 to the second power gives me
Oh.
4. And 1 times 4,
4.
there's your second term. And now plug in 3, and then hopefully you'll start to see what the pattern is. What's negative 1 cubed?
Isn't that negative 1?
That's still negative 1, and negative 1 to an odd power is always negative 1. And what about 2 cubed? 8. And that gives me negative 8. So what's happening to the number each time?
W. Or, I don't know.
Multiplied by negative 2.
Yeah, it's basically being multiplied by negative 2 each time. It's doubling, but it's also becoming positive and negative, going back and forth. Yep. Okay. And then to get the 15th term, the point of that one is just to show you, you don't need 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You can skip all of them and jump right to the 15th. Okay. What's negative 1 to the 15th?
-1.
Still negative 1. And then 2 to the 15th. It's a pretty big number, but it's not that huge. 32,768.
Not that big.
Not that big.
I wish my bank account was not that big.
It's small.
And what do you get when you multiply that together?
-32,667. You know what I mean?
768.
Yeah.
So that's another example of just finding the first 3 terms and then skipping to any term they want to know. Any question on that?
I like when they give you the formula and you just have to put the number.
Yeah, so there will be some, you'll have some like
The
that.
whole test should just be that.
Okay, so the kind of formula that is what I've been calling like the good formula, the one that's easier to use, that is called an explicit formula. An explicit formula allows you to find any term you want to know right away. So you want to know the 304th term, you plug in 304, and there's your answer. So an explicit formula is generally a little harder to figure out, but it's a lot more useful. The other formula is called recursive. A recursive formula is very easy to figure out. It's where you look at a pattern and you say, all right, I'm adding 3 each time. But if you want to get to the 400th term, you're going to have to add 3 that many times until you get to the term you want.
So what's the definition for that?
So recursive,
Yeah.
that's the kind of formula where I start you off with the first couple. Maybe something like this. And then I say, what would the 200th term be? There's no easy way to find the 200th term quick. Because the pattern here, if you just say it's adding 3 each time, well, you've got to add 3 190 something more times until you get all the way to 200. That's a recursive formula. So I'll give you the first few terms, and then the way you find the next term is by doing something to the previous term. Not the best way to do it. Easy to come up with that formula, but it's not very useful. It takes a long time. Does everybody have the explicit formula? Cut off one word. The last word was sequence. I had to cut off. So let's try doing a recursive formula. And they want us to list the first few terms. Okay. What is the first term in this form, in this sequence?
2.
2. How do you know that?
Because it says it is.
Because it's given. Okay. In a recursive formula, I have to give you the first one. I can't just give you something like this and say, find the first one. Recursive, I have to start you with the number. So I started you off with 2. And what is this basically saying to do?
To add 3.
To,
A-N minus 1.
which is really the
First.
The last.
the one before. So if you had to explain that to somebody that doesn't understand what that means, it just means take and add 3 to the one before you want it, the one before you're trying to find. Okay? So we're going to try to find the second one. So we're going to add 3 to the first one.
So 5.
So it would be 5. Now to find the third one, you have to add 3 to the second one. So you get 8. And if you wanted the 50th term, well, you're going to have to work your way up to it, and it's going to take a while. Okay. Besides taking a long time, the other thing is if you make one mistake, like let's say you put 4 here, and then you add 3, well, if you make one mistake, then everything you build on that is wrong. How about if they wanted the 4th term? What would that one be?
11.
11, yep. And that's recursive. So now let's try this one. It says determine the first 4 terms and the 8th term using this information. Okay, so what I usually do is I make a table. In the bottom row, I put the position. In the top, that's the term in that spot. What is the first term in the sequence?
4. No, 2.
2. How do you know that?
It's given.
It's given. They had to give it to me because the formula is recursive. So the first term is 2. What's the formula basically saying to do? If you had to simplify that so somebody reading it would understand it if they don't know what all that means.
Follow the pattern.
So how would you describe the pattern? I don't think they see the pattern in that one. Well, what is this box telling you to do?
That's the equation.
That's the
for
pattern.
2.
You add 4 to the number before the one you want to know.
You add 4 to the one before you want to know. Yeah. It's adding, to find a term, add 4 to the one that came before it. So if you want to know the second term, add 4 to the one that comes before it. So what's the second term? 6. And the third term? 10. And the fourth term? 14. Now, because we're trying to find, we want to go all the way up to the 8th term.
Yeah.
Do I have the 7th term?
No.
No. So I need that. But to get the 7th, I need the 6th. To get the 6th, I need the 5th. So I have to work my way through all of them. This is not, that's why this formula is not as good as the other kind. So what's the 5th one?
18.
18. And the 6th one? 22. And the 7th one?
26.
And the 8th one? 30. And if we make any mistake in all those terms, then it's going to make the 8th one wrong. But that's what they asked us to do. So any question on how we found those terms using this recursive formula? Okay, so any question on the difference between recursive and explicit? So now let's see if we can take something that they give us that's recursive and change it to explicit. To do that, let's list out, let's do the first 4 terms. What is the first term in this one? How much? 3. How do you know that? Yeah, it says it. It has to be given. Okay, if it's a recursive formula, they have to start you with the number. So the first term is 3. And what does the formula say to do to get the next term?
Add 5 to the one before.
Add 5 to the one before it. So I want to know the second term. So I'm going to add 5 to the first term. So what's the second term?
7.
Careful. You want to add 5.
8.
8.
But is that a minus 1 at the end, or no?
So A sub n means the word current term. A sub n minus 1 is previous. So this, to get the current term, take 5 and add it to minus 1 means before,
Okay.
previous. All right, how about the third term?
Uh, 11. 12.
So the rule is to add 5 to the one that came before it. 13. And the fourth term?
18.
18? Let's do that. How about the fifth term?
23.
23. Okay. So now if I said, what's the 100th term? Well, we'd have to keep adding 5 till we get there. So instead, let's see if we can convert and figure out what can you do to that number to change it into that number. So what can you do to the position number to get the result? Don't want to look back at the previous term. Does anyone see what you can do to 4 to turn it into 18? And part of the hint is going to be, if you look at the original information they gave us, there's a hint in there at what you need to do to it. Yeah?
Maybe like times 5 minus 2.
Yep, that's exactly what it is. It's times 5 minus 2. If you multiply 5 times 5, you get 25. Minus 2 is 23. 4 times 5 is 20. Take away 2 is 18. So that's the pattern. Multiply by 5 and minus 2. So now, if I said to you to find this, it should be very easy. Just plug in the number 100. What's 5 times 100? 500 minus 2? So whether you want me to find the 100th term or the 500th term, I can find it just as quick now that I have this formula. What's the name of this type? Explicit. And what's the name of this type?
Recursive.
Recursive. Which one is easier to use?
Explicit.
Yeah, explicit is a lot easier because you can find what you want right away. You don't have to worry about anything else.
How would that work? Because for the first one, I think 1 times 5 is
5. And what's 5 minus 2? 3. Yep. So it does have to work all of the time. But generally, if you find one that works for like 3 or 4 of them, it's probably going to work for all of them. And this was a big hint. A 5. Okay. The patterns here, they can get pretty complicated. But in general, I'm only going to give you ones where you have to multiply and then add or subtract. All right, let's look at this one. How many people have ever heard of the Fibonacci sequence? You hear that? Fibonacci? Yeah, it's another special sequence, and it is recursive. It's recursive. This one is a pretty hard one to convert to explicit. So we don't look at that in this class. Looking at this, what's in that blue box? Anybody think they can tell me what that means? To get a particular term in the sequence, what is this telling you to do?
1 plus 1.
Be more, to get this one, yeah. But how about in general now?
The equation is saying that in order to get the current value, you have to add together your previous two.
Right. This says to get the current term, take the one before it and the one before that and add them together. So this is a recursive sequence that depends on the 2 previous terms. Okay, so I want to get the 4th term. What am I going to add together to get the 4th term?
2 and 1.
The 2nd term and the 3rd term. How about the next term after that?
3 and 2.
We're going to add the 2 that came before it. 3 and 2 gives me 5. And they want 1 more. How am I going to get the next term?
5 plus 3.
Add the 2 that came before it, and it gives me 8. Pretty challenging formula to make it explicit. So if I said to you what's like the 200th Fibonacci number, you would have to just keep adding them up till you get there. Or try to figure out some faster way to do it. Any question on that? It's called a Fibonacci sequence. All right, so we've had a couple sequences where the pattern has been like add 3, add 4. Anytime that you are adding and subtracting a number over and over, that is called an arithmetic sequence. You can say arithmetic, you can say arithmetic. I usually say arithmetic when I'm talking about like 2 times 5, that's arithmetic. I've always said arithmetic when I'm talking about this kind of sequence. Another word for sequence, in case I haven't used it, is called progression. Sequence of numbers, progression, same thing. So what would make something arithmetic? Yeah, that's what I'm going to show you right now. A sequence is arithmetic if to get the next term, you take the one before it and you add something. You take the one before it and you add something. Now, you could add a negative number. That would be subtracting. That's fine too. But whether you're adding or subtracting, that is called an arithmetic sequence. Here's an arithmetic sequence. What am I adding each time there? Two. Yeah. The number that you add each time in this formula, they call D. It's the number that you add each time. I'll just word that a little differently. So D is the number you add each time. If you are not adding a number each time, then you do not have an arithmetic sequence. How about something like this? Am I adding the same number each time? No. Like the first one is a +3, but then it's a +6. Then it's no. So I'm not adding the same number each time. That is not arithmetic. It is something else. Does anybody see what the pattern is in that one?
Multiplied by 2.
Right, the pattern is timesing by 2. Okay, well, that'll be the last one we talk about. Okay, so that is not arithmetic. Arithmetic, you need to add or subtract. And I'm going to show you a quick way to figure out the formula for an arithmetic sequence. So when I first put these up, I asked someone, can you figure out a pattern? Where was it? Yeah, it was this one. I asked, can you figure out a pattern? And somebody figured out that it was times it by 3 and -1. Well, how do you get that? If you're not sure or you don't see it, how do you know you multiply this by 3 and then -1? I'm going to show you a way you can figure this out automatically, okay, without having to try to guess. Here is the formula to figure out the pattern in an explicit sequence if you are adding a number each time. The formula is the first term plus n minus 1 times d. And we're going to try that on the problem we already did. So it's the first term plus n minus 1 times d. What this formula does is it basically takes all the guesswork out of figuring out the pattern. Is it times 4 minus 5, or is it times 2 plus 7? You don't have to guess at all. This will give you the exact answer every time. So the first term plus n minus 1 in parentheses times d. So let's go back and try that on the very first problem we did. So here's this pattern, 2, 5, 8, 11. And let's say you don't know how to get this. How did somebody figure out this triple and minus 1? Well, this is how you can figure it out. What was that formula that we just wrote down?
an equals a1 plus n minus 1 times d.
Okay, so I'm telling you that that's going to give you the same result we just got, but you're not going to have to really figure anything out. You're just going to have to plug in. There's two things you need to know. The first term, and d is what you add each time to get from one to the next. So look at this sequence of numbers. What's the first term? Two. First term is 2 plus n minus 1. And now d is what you add each time. What are you adding each time to get from one to the next? 3. Let's do that out and see if it gives us the same answer. Distribute that. What's 3 times n?
3n.
3n. And 3 times negative 1?
Negative 3.
Negative 3. Okay. Combine like terms. What's 2 take away 3?
Negative 1.
Negative 1. It gives us exactly the same answer that we got over here. Except you don't have to try to figure it out now. Any question on that? We'll try that another one. All right. So I want to find an explicit formula for that. Now, if that's all I gave you, that's impossible. Why is that one not doable?
Because you don't have the first term.
I didn't give you the first term, and it's a recursive formula, so I got to tell you where to start. Start at 5. Okay. What's the formula that we wrote down to figure it out when you're adding the same thing over and over?
an equals a1 plus n minus 1 plus d.
Times d.
Times d. Yep. Now, if I want, I can write the first few terms off to the side. It's 5, and then add 3. 8, add 3 more, add 3 more, right? And when I get my formula, I'll check and see if it actually works. So this is the first term, second term, third, and fourth. All right. Fill in for these two things. What is my first term? 5. Noah, how do I know my first term is 5? Noah. And Brett. Sorry. No, I don't know.
Because it's stayed up top.
Yeah, they give it to us at the top. First term is given it. First term is 5. Right. Plus, leave the n minus 1 just the way it is. And d, Logan, what's the number that I'm adding each time? 3. Let's do that out, and then we'll check it and see if it works. All right. 3 times n gives me
3n.
3n. 3 times negative 1?
Negative 3.
Negative 3. What's 5 minus 3?
3n plus 2.
3n plus 2. So we can check our formula by plugging in a number and seeing if it works. If we plug in 4, we should get 14. Let's see. What's 3 times 4?
12.
12 plus 2?
13.
Perfect. Let's check it for 3. What's 3 times 3?
9.
9. 9 plus 2?
11.
11. So it seems like it works. So now if I wanted to know the 100th term, it's going to be 302. Very easy to find. now that we figured that out. Right, but that takes all the guesswork out of it, so you don't have to try to guess. Any question on how we got the first term, the D, or how I simplified it? All right. And let's try to do the same thing again. Okay, it says the first two terms in the arithmetic sequence are given. Find an explicit formula. Well, let's start with the formula we need to plug into. Someone remind me one more time, what's that formula?
A1 plus n minus 1 times d.
N minus 1 times d. So we need two things, this and this. What is the first term in our sequence? Negative 8, it's given. D is what you add each time. So you have to figure out what do you add to get from negative 8 to negative 2. D is 6, plus 6. So now fill those in. First term is negative 8. And D is 6. And then combine like terms. What's 6 times n?
6n.
6n. What's 6 times negative 1?
Negative 6.
Negative 6. But then you also have another negative 8.
Negative 14.
That's negative 14. And that's it. That's your formula. Let's check it. That's the first term. That's the second term. Let's check it on the second term and see what happens. If it works, when I plug in 2, I should get this term right there. What's 6 times 2?
12.
What's 12 take away 14?
Negative 2.
Perfect. It gave me exactly the number I was hoping. And if you plug in 1, you should get negative 8. 6 take away 14. Yeah. All right. So now if I said use that formula to find the 100th term, what would you fill in for n?
100.
Yeah. So you'd have 600 take away 14. That's the 100th term. All right. Any question on that one? Yes? Yep, just sign up for me. Okay, find a formula for the sequence. Same kind of question. What's missing this time?
The beginning.
Yeah, we don't know the first term. But we have enough information that we can figure it out. We know two terms. Are the two terms we know next to each other? No. So then we don't know D right away. But how many, we'll call them like jumps. How many jumps are we going to make to get from the third term to the 8th term? 5 jumps. What's the distance between 13 and 3, like on a number line?
10.
It's 10. So you have to go 10 units in 5 jumps. That means each jump would be how much? 2. Yep. So each one is a jump of 2. Is it a jump of 2 up to get from 13 to 3 or down?
Down.
It's down. So let's go by 2s. 11, 9, 7, 5, 3. Perfect. But we need to go back the other way to get the first term. So what's the second term going to be? 15. And the first term? How much is it?
17.
17.
Okay, no. At least I said something.
Yeah, 7. Did you say 18 first?
Yeah.
That's okay. Okay, so we got the first term. What is it that we add or subtract each time as we go to the right?
2. Subtract 2.
Subtract 2. So make sure we put negative 2.
You said, what do we subtract?
Well, I said add or subtract.
I heard what.
Okay, so this time make sure D is a negative because it's going down. And then use the same formula. Okay, what's the formula again?
A1. Go ahead.
A1.
Negative.
No, N minus 1 times D.
It's D. First term is 17. And the D is negative 2. Okay, what's negative 2 times N?
Negative 2N.
Negative 2N. Negative 2 times negative 1?
2.
2 plus 17.
19.
19. Okay, and let's pick a number and check it. Let's try 5. So if we plug in 5, that's the result we should get. What's negative 2 times positive 5?
10. Negative 10.
Negative 10. And what's 19? Take away 10.
9.
Perfect. Yep, it works. Okay, so you just pick any number and check it and make sure it works. All right, so that's arithmetic. Any question on that one? All right, so last sequence we're going to look at is geometric. So the idea of geometric, it's very similar, except you do not add to get from one term to the next. You multiply. You have to multiply by the same thing each time. Just like you add 2 each time, this could be multiplied by 2. But it's going to be the same thing each time. So if I gave you this, let's say 2 and then 4. If I said that that was arithmetic, what would the next term be? 6. If I said it was geometric, what would the next term be?
8.
Yes. Yep. 8. So if I just give you 2 terms, that's not enough. If I gave you 3, that's enough. If I gave you 2, I could just say it's geometric or arithmetic. I could just specify. Okay, so that's a geometric sequence. Okay. R is what you multiply by each time. So this is taking the place of D. There's no more D. So R is what you multiply by each time. All right, and let me show you the formula for that. So explicit formula for a geometric sequence. A sub n equals A sub 1 times R to the n minus 1. So that's taking the place of that formula you had before. And we'll check it on a couple, make sure it works. But it's A sub 1 times R to the n minus 1. I think I wrote the same thing down here. Yeah. I just wrote the same thing twice. Let me leave that up. Right, so it says to find an explicit formula for the geometric sequence. Because it's geometric, what are they telling me the pattern is? Adding or multiplying? It's multiplying. So we've got to look at what do you multiply by each time to get from one to the next. And we have 2 right next to each other. So that makes it easier to figure out. So what are we multiplying by?
-2.
Yep, multiply by -2. So if they wanted, what's the fourth one going to be?
And negative 24.
A -24. And the fifth one? Positive 48. And the sixth one?
56. -56.
96. But to use this formula, it's great. We know it's multiplying by -2. What else do we need to know?
The first term.
Right, we need this.
So you're just about
So what would the first term be?
3.
3. And what did we multiply by each time?
-2.
-2. Okay, fill those in, and let's see if it works. So to find any term you want to know, take the first term times r, and you don't do that out, you just leave it, to the n minus 1. Let's check it. Let's check for the fourth term. So if I plug in a 4, I hopefully am going to get -24. If you fill in 4, what's 4 minus 1? 3. What's -2 to the third power? -2 times -2 times -2.
12.
So -2 times -2 is how much?
Oh,
4 times -2 again? -8. What's -8 times +3?
Negative 24.
And that's exactly what we were supposed to get. Yep. So the arithmetic's a little harder. Like if I said find the 100th term, you'd have to raise -2 to the 99th power. But you just use your calculator. Okay. Any question on that one? Right, that's how you find the pattern for a geometric sequence. No, this will all be on the midterm though. Yeah, that's the right thing. Yeah, so this will be on the midterm. So tomorrow we're going to do half of 11-2, and that's the last lesson in the algebra part of the class. And it's a perfect place to end because we're at the halfway.
Do we have a test tomorrow?
Yes. I think he just answered.
Tomorrow?
It's about 7.
No. No test tomorrow. So homework, just be careful when you write it. There's a lot of odds. So it's 1 through 5 odd, 9 to 13 odd, 14 is the only even, and then 17 to 27 odd, and 31. Okay, you've got about 15 minutes left. Okay, so we can use the time to get started on that. If you have questions, you can ask me. Graphing calculator, definitely shouldn't need that for the homework.